what goes in the first set of parentheses?
Same
H. Same sign would be a minus, yeah. And what else? H minus what? 3. The cube root of 27 is 3. Very good. And that parentheses is very important because everything goes off of them, okay? So the very first thing you do is you square the first one. Square H, and what do you get? H squared. There you go. Then the opposite sign. Then you multiply them together.
Wait, don't you need to
Yeah. Thank you. Then you got an opposite sign. Then you multiply the two together. What do you get? 3H. And then that last sign is always positive. And then you square the second one, and what do you get? 9. There you go. And that's all she wrote. That's all. That's all. The hard part comes in whenever, if it was equal to 0, and then you would have to use quadratic formula on this guy. But we don't. It's not equal to 0, so we don't have to do that. All right. What about number 6? You got 3 terms, but you got a number in front. So what do you have to do? There you go. You got to slide the 2, no matter which way you do it. If you do bust them up, or if you do the slide divide thing, you still got to multiply the 2 times the 9, and then go from there. So, what are the factors of 18 that add and subtract to be 3? 6 and negative 3. There you go. There you go. Alright, so if you're doing the slide divide, then you've got this. Everybody good with that so far? If you're doing bust them up, you got that. Everybody good so far? Doing 2 different ways. This is bust them up. This is the slide divide. Alright, if you're doing bust them up, then you got to do grouping from there. If you're doing the slide divide, you can't stop here. You have to divide by that number you slid, which was 2, right? If you're doing bust them up, that'd be 2n and n plus 3 and negative 3. What? Come on, get it.
This number 11 receiver went to Clemson.
I went to Clemson.
Justin Ross.
Good.
We had our class.
I felt like I would have whispered it.
Who's
Parker is right
there. We'll get on this. Let's do this first. All right, here we go. So we're doing slide divide. That's n plus 3 and 2n minus 3. We're okay with that one? If you're doing bust them up, then let's see, it's n plus 3 and 2n minus 3. Same thing. Yes, ma'am.
Why 2n minus 3?
Because which one? This one?
Oh, the first one.
Okay, because 3 will not divide by 2, so you do bottoms up. So you do the bottom number comes to the front as 2n and then minus 3.
Okay.
So if it had been n minus 5 over 4, that doesn't divide. So you do bottom number comes to the front. So that one will be 4n minus 5.
Okay.
Got it? But this one, 6 over 2, that did divide. So you can just say n plus 3.
Okay.
All right. Any questions on bust them up or the slide divide way?
Wait. Is that bust them up for that one?
That's bust them up.
For which one?
For number 6.
It is good.
Good. We can turn air on it. Who's confused? On number 7? Okay, number 7 has 2 terms, right?
Yeah, there you go.
Alright, 7 has 2 terms, but it has an exponent of 3, so we use SOAP with that. Good with that so far? Alright, so what would go in the first parentheses? Cube root of 8. 2x, and then what else? Same sign, plus 5. There you go, 2x plus 5. Very, very, very good. How are we doing so far? We good? And then everything goes off of the 2x plus 5. Alright, you square the first one. So square 2x, what do you get? 4x squared. There you go. Then you've got the opposite sign. Multiply the 2 together. 10x last sign is always positive. Square the last one, you get 25. There you go. Good? Mm-hmm. All right. Okay, what about number 8? Number 8 is different because that is a fourth power, not a third power. Show. What, say that again? What do you mean the same operation? No, we don't use soap. Only use soap when it has an exponent of 3. We have an exponent of 4 here.
Just do differences.
Difference of 2 squares. There you go. Alright, so x to the 4th breaks up as x squared and x squared. A minus sign would break up as a plus and a minus. And then what's the square root of 256? 16. Very good. But we're not done yet. Yep, because this guy right here, x squared and 16 are both squares, and you got a subtract sign. So you're going to bring down the x squared plus 16 and break up the x squared minus 16. No, 2 x's would be x and x.
Yeah, that's what I want.
Yep, there you go. Alright, then you can't take it any further because even though it's a difference of 1 square, not a difference of 2 squares, because the x is not squared. That's as far as you can take it. Good to go?
Mm-hmm.
Alright.
You couldn't simplify it.
You could not simplify it anymore.
Not the x squared plus 16.
No, because if you were to split that up and FOIL it, it would not give you back. It would not give you back the same thing. You want to do the subtraction ones. All right, here we go. Grab your ACT.
Dang it.
What time are you leaving at 1 o'clock? Yeah, we should be done by then, hopefully. All right, here we go. We got 19, 20, and 21 on the back of that ACT from Friday. 19, 20, 21. Don't start yet. You got your letter of the day in your head? A, B, C, or D? Don't pick E as the letter of the day. Don't start yet. Don't cheat. Don't start yet. All right, we're going to have 3 minutes. Everybody get ready to go. 3 minutes. Don't start yet. Don't start reading.
Sorry.
Okay. Ready? And go. 3 minutes. 3 minutes. Alright guys, go ahead and put that in a safe spot and let's grab our notes from, that I gave you yesterday. So, that's all. I have like a big cup of pen. I have like a small one. Got either this. Alright, here we go. So, what happens if I were to multiply x times x? What would you do to the exponents? How? What'd you do? You'd add them together. There you go. And remember that a logarithm is just another way to do exponents, okay? So when we do these properties, these three properties, they're the same thing as our exponent properties. So right here, product means multiply, right? When you multiply the bases, what do you do to the exponents? You add them. So to take this one logarithm and break it into two logarithms, you're going to add the two of them together. So you're going to have a log base x of that first guy, a, and then you're going to add another logarithm with the same base of that other guy, b. And that's it. So you took one logarithm and you split it into two. Or you could go backwards. If you had two logarithms that you were adding, how would you make it one logarithm if you were adding? What would you do to them? Okay, let's just go backwards. Ready? If you have two logarithms and you're adding, how do you go back to one logarithm?
Try.
You multiply. Multiply. Just like it's just the same thing here. There you'd multiply the bases, you'd add the exponents, right? Same thing here. If you're going backwards, take that adding. It would go back to multiplying. Just going back and forth. All right, let's do division. What if I were dividing those two bases? You would subtract. So you're doing the same thing here. Quotient means division, and you're going to subtract those two. Notice that I started with the numerator. The a came first with the numerator. And then log base x of b. How are we doing so far? What if we were going backwards? So we took one logarithm and we split it into two. But if we had two logarithms that we were subtracting, how would we go backwards? You divide them. Are you okay with that so far? All right, here we go. Power. This is a little bit different. Okay, so this power is p, right? He's going to go in the very, very front. So you got p log base x of a. That's it. Those are the properties. All right, here we go. So write each expression as a single logarithm, right? So they give us two logarithms, and we're subtracting. So what did we do to exponents when we subtracted the exponents? We were doing what to the bases? We were dividing them, right? All right, so we've got log base 3. And the only reason this is legal is because they have the same base, right? And the very first one is 20, so that's my numerator. And the second one, 4, is my denominator, so it's 20 over 4. Everybody okay with that? But you can take that further. What can I do?
Divide.
What's 20 over 4? 5. So this is log base 3 of 5. And the directions said to write them as a single logarithm and evaluate if possible. If possible. You got to remember, how do we do this? What was the question that we asked ourselves? What power of 3 gives you 5? Is there a power of 3 that gives you 5? So we're done. Just like on your test, you had something like the fourth root of some random crazy number or whatever it was. You couldn't take it any further, so you left it, right? But if you could take it further, you actually gave me... It's my ring that messes it up. All right, here we go. Number 2. You've got a 3 in the front, so he goes as my exponent. Is everybody okay with that? The number in front with logarithms? Just like our power rule right here. We're just going backwards. Number in front was our power. All right, so we've got log base 2 of x to the third plus log base 2 of y. Say that again. Very good, because when we're adding the two logarithms together, to smush them together as one logarithm, we would multiply, right? Okay, so that'd be log base 2, x to the third, 1. How are we doing? Are we okay? No, just kind of staring, like there's no expression to your faces, so I don't know if we're good or bad.
Well, as long as you're doing it.
As long as we're doing it. Okay, well good. When the next 10 minutes, when we do the logarithms by ourselves, we'll see how we do. Alright, let's look at number 3. What you see first? You see addition, and you see a power, right? You see the 4 in the front, goes to the 2. Alright, so we've got log base 4 of 2 to the 4 plus log base 4 of 4 minus log base 4 of 16. Okay. All right, see anything else we can do before we start doing all this crazy property stuff? Simplify. What's 2 to the 4th? 16. There you go. So you got log base 4 of 16.
Oh, can't they like white terms like you
Sorry. Nope, you good. All right, and then Noah, tell us what's going on.
Well, you can just take away your two white terms.
Very good. Log base 4 of 16 minus log base 4 of 16 cancel each other out, right? So you're left with log base 4 of 4, and you can evaluate that. Question you're asking yourself is, what power of 4 equals 4? No. 1. X4 to the first is 4. Now, if this was 0, then if this was 1, then your answer would be 0. Yes. So it's just 1. How are we doing? We okay? Kind of, sort of? Are you awake today? No, there's like no expression at all to your faces. So, yes, sir.
So why is it 0?
Because 4 to the first is 4. 4 to the 0 would be 1. And it's supposed to equal 4, not 1.
Or the 1 is just 4.
Alright, let's go to the next one. Here we go. Same thing. How many logarithms they give you? They give you 1 logarithm on number 4. Alright, but before that, let's answer this question. Can you write 3 log base 2 of 9 minus log base 6 of 9 as a single logarithm?
No.
Why? Because they're not the same base. Just like that problem on your test. They were not the same base, right? So no solution, or you could have written prime, or you could have written not possible. Any of that stuff I would have taken, okay? Alright, so let's look at number 4, though. Number 4, you're dividing x and y. So how do I split them into 2 logarithms? How? Add, subtract, multiply, divide. Subtract. When you divide the bases, you subtract the exponents. So we don't normally like to use more than 1 logarithm, but it asked us to here. Alright, let's look at number 5. What has the 4th power? The 3, the r, or everything? Just the r, because it does not have parentheses around it. Is everybody okay with that? Alright, so when I'm multiplying the 3 and the r. So how do I split multiplying into 2 logarithms? You add them. There you go. So you got log base 5 of 3 plus
4.
You gotta put the 4 first. 4 was the power, then log base 5 of r. How are we doing? The 3 went right here. Remember, he didn't have parentheses, so the 3 doesn't have the exponent. Just the r had the exponent. But if it was like this, then they would both have a 4 in the front. But it doesn't have parentheses on it, so we're going to leave it alone. All right, what about 6? 6 has parentheses, right? So both of them have what exponent? 2, but I'm dividing them. So how do you split dividing into 2? Subtraction. There you go. So you can have a 2 of y. Yep. Minus. Both have the 2. 2 log base 2 of 3. There you go. Very good.
Well, I know what it is. I'm just saying it wrong.
It's fine. As long as you write it down right, it's fine. All right, what about number 7?
3 log 7.
Log base 7, yeah. Of
A.
A. Notice how A is not a power. There were still several of us trying to write A as a power. Like, look, this is what several of you are writing. Like that. You see the difference between this and that? This is a no-no. Don't do that. Don't do that. Okay? This is not an exponent. It's log base 7 of A. Because some of you are trying to tell me it's 7 to the A power instead of. Alright, so we're multiplying. So to split them apart, you're going to add them.
4 log base 7.
Very good. Very good. How are we doing so far?
Another one.
Did you put your name in?
Mm-hmm.
What do you know?
Oh, it's on the side.
We're fine. Don't worry.
Well, hold on.
What?
I got it.
Jesus. All right, last ones. Here we go. We're going to solve them. No, not today. We'll do that. We can take checkpoints away and y'all just take your test instead.
I mean, I like them, but just not today.
I know. We don't need them today. We will have one, what's today? Today's Wednesday? Tomorrow or Friday? I can't remember which one. Tomorrow or Friday. All right, here we go. So these are different. These are different than your test because you don't have a log on both sides. You don't have a log on both sides of the equal sign. They're both on the same side. Y'all okay with that? All right. So when you add the logarithms together with the same base, you multiply their pieces. So you're going to multiply x and x minus 9. Now it is just like your test. You have one step, and now it's just like your test. All right, you only have one logarithm, right? So you can't set these two pieces equal. The only time you can set the two pieces equal is if they have a log on both sides. Y'all okay with that? Mm-hmm. So we're going to do this little 6 to the second power equals x minus 9 deal. Y'all okay? We're going to rewrite it. The little, the base, hold on.
All right.
The base is 6. Whatever it equals is your power.
Okay.
And then all that good stuff. Yes, ma'am.
Can you go ahead and distribute the x?
Okay. Yep. So we'll go ahead and distribute this x right now. And guys, can you actually tell me what 6 squared is?
36.
Yeah, so go ahead and write it. Yes, you can. You can go ahead and write it as 36, okay? The time when you have to get their bases the same is if you can't actually tell me what 6 to whatever power is, like if you have an x or something, okay? Yeah. And now it's still just like your test. Subtract it. There you go.
I'm here, but I'm not here.
I know. All right, now what are the factors of 36? Negative 36. The adder subtract be negative 9.
Negative 12 and 3.
Oh, it's negative.
Wait. He had it. It was negative 12.
Oh, negative 12 and positive 3. I'm sorry. I was thinking you said negative 3. I'm sorry. You're right. I'm sorry. You were right. I was thinking you said negative 3. All right, so what are my two answers?
12 and negative
12 and negative 3. Well, we got to check. Oh, I just circled them. We got to check them and make sure that they work, okay? So let's plug it in. Here we go. So if we plug in 12, what's 12 minus 9? What's 12 minus 9? 3 times 12 is 36. Is that true? Is 6 to the second power 36?
Yes.
So 12 works. He's good. All right, plug in negative 3. What's negative 3 minus 9? Negative 12 times negative 3. Positive 36. Check it. Is 6 to the second power 36? They both work. There you go. All right, let's look at number 9. Number 9, here we go. All right, we've got a 2 in the front. Got a 2 in the front. So where's he go?
Not x.
He goes, is the exponent the power? There you go. So log base 7 of x to the second power. All right, well, we got 2 logarithms on the other side. I don't want 2 logarithms. I want 1 logarithm. So smush them together.
it's
it's
log
multiplication.
Multiplication. What's 27 times 3?
81.
81. There you go. So log base 7 of 81. Are you okay? All right. You've got one logarithm on both sides with the same base. So you get to drop their logarithms and set their pieces
Good grief.
equal.
About time.
Now, how do you get rid of the square with the x? Square root it, and what is the square root of 81?
Plus minus
Gotta have both of them because it's two answers. You got a positive 9 and a negative 9. All right, let's plug it in and check it. Here we go. 9 squared is 81. That works. Negative 9 squared is also 81. They both work. Very good. All right, let's go to number 10. Here we go. Number 10, number 10, number 10. We are adding logarithms. So what would we do? Multiply their pieces. There you go. So we got log base 6 of x times x plus 5 equals 2. And I only have one logarithm, so you got to rewrite it, okay? Not yet. You got 2 problems. Project 1. All right, so we got to rewrite this, right? So we've got 6 to the second power equals x times x plus 5. I'm trying to have that line up. We good? Everybody okay? All right, can you actually tell me what 6 squared is? 36. There you go. Distribute. Move the 36 to the other side. What's the factors of negative 36 that add or subtract to be positive 5? 9 and what? Negative 4. There you go. So what's my 2 answers? Negative 9 and 4, right? Make sure they work. Here we go. Make sure they work. So negative 9 plus 5 is? Negative what? Negative 9 plus 5. Negative 4 times negative 9 is 36. Is 6 to the second power 36? Yes, that one works. All right, plug in 4. Here we go. What's 4 plus 5? 9 times 4 is 6 to the second power 36. Yes, we got one more. Here we go. Last one. Here we go. We got a number in the front. So where's he go? Exponent. Log base 2 of x squared minus log base 2 of 5 equals log base 2 of 125. Say that again. You would use division on this side. Very good. These two right here, when you subtract them, you use division. First one is your numerator. How are we doing? It was right here in the problem.
Oh, okay.
All right, you've got a log on both sides, right? So you drop their logarithms, set their pieces equal.
It's subtraction.
Yep. And then we multiply by what? There you go. 5's cancel. So x squared is equal to, what's 125 times 5?
625.
How do you get rid of a square? And what's the square root of 625?
Plus or minus 25.
Plus and minus 25. Due to time constraints, I'm going to both tell you they both work. All right, Michaela, no, bye. See you later. See you in a week. Michaela, see you tomorrow. All right, so from there, on the back of that page are 10 problems. Guess what those 10 problems are? Homework. And you've got 22 minutes to get your homework done in class. I'm going to come around and I'm going to check them as you go. And if one of them's wrong, I'm going to tell you. And so there ain't no reason why you shouldn't get 100 on this homework. We can technically consider this a check one. Technically. I know. Keep up with everything while you're gone, okay?
Yes, ma'am.
All right. Bye, Michaela. On the back page, 1 through 10. Yep. Shoot. All right. I want you to look at number. Where's that? Number 7. Look at number 7. Number 7. Number 7. Number 7. See it? Does that x minus 3 have parentheses around it? No. Which means that 3 does not go with the x.
It goes with the logarithm.
He is a power, and it goes with a logarithm. Very good. Does that make sense to everybody? Subtraction.
Okay.
So that would be what? Division. There you go. There you go. If it had parentheses, that would mean something different, but it doesn't have parentheses, okay? All right, 1 through 10. Y'all try those. I'm going to come around and check them, and if there's one that's wrong, I'll tell you so you can try to get 100.
Another piece of paper.
I have got a school, we have no idea what it is.
All right, then let's do this. Go to Officer Parker and report it stolen until you find it. And that way, he'll send an email out to everybody and they can be looking for it. Because I already know what it looks like, and I'll look and I'll keep an eye out for it.
Is it the same one?
Yeah, it looks just like that, but it's got his name on it too. So tell him.
On the side thingy.
Tell him it's. Yeah, but if there's a calculator that doesn't have a slide thing, a case, then we'll all know. Sorry, Brett. And they got the same number in there. Divide by the pieces, that's what that. So something at the same logarithm, you drop that logarithm. And it's 8x equals. There you go. Yeah, there you go. Sometimes it just helps if you write it down and you can see it better.